Okay, so it's time to do our third video for exam 0. And here we go. So we're up to problem number 13. So as usual, let me try to be consistent and put in the title. So exam 0 review C. Okay, here comes problem number 13. Radicals again. Square root of 8 plus 7 square root of 72. Okay, we try to add this together, forget it. They're not like terms, but they like these problems because maybe if we simplify the square root of 8 and we simplify the square root of 72, something good might happen. We've seen this before. So square root of 8 we can split into two. One of them is perfect square 4. It's on the list, right? Don't forget our list. Might as well put it here. I could have put it on a previous video. 1 is the first one, then 4, then 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Okay, now if 8 breaks into 4, 4 times 2 gets you back to 8. So here's the leftover. Hopefully those terms sound familiar from the recent past. 72 we can break into a perfect square. What's on the list that is one of the multiples of 72, one of the factors of 72? The answer is 36. That's the highest one on the list. We want the highest one on the list. 36 times 2 is 72. So you can see where we're going. There's an invisible 1 here, so nothing happens there. Square root of 4 turns into 2 square root of 2. An invisible 1 doesn't do anything. But this 7, don't forget this 7, times, it's coming down now. I'm bringing it down. Square root of 36 is 6, and square root of 2 is just a leftover. What do I have? 2 square root of 2. 7 times 6 is 42 square root of 2. And now we've got like terms that we can add together. That equals 44 square root of 2. And now the problem is over, but we were able to add them in the end because they turned into like terms. Okay, here comes 14. What about the cube root of w, or you can use any letter obviously, to the 17? So if there's a 3 here, we have to worry about what's the largest number below 17, which is divisible by 3. Largest number below 17 divisible by 3. Answer, well, we're dividing into 2 cube roots here. Let's be very formal and write everything out. Into 2 cube roots. So we put 15 on the right, that's where we put the perfect cube roots, and the leftover, which we can do nothing about, is W2. 15 plus 2 gets you back to 17. How much is that? The cube root of 15 divided by 3. 15 by 3 is 5. So I have W to the 5, W to the 5, and the cube root leftover, W2, there's nothing we can do about it. And therefore, we leave it completely alone. So there is our final answer. Okay, yes, I can, let's go to another sheet below this. I think I can do something here with the paper. Let's move this up and take care of problem number 15. Let me just get one more on here, even though it's a little crowded, but I can get one more on here. The problem number 15 is, what about the cube root of w, I'm sorry, not w, 5y to the 12. 5y to the 12. Okay, so we could split this into 2 pieces. The 2 cube roots, the leftovers, and the perfect cubes. What about y to the 12? Is that a perfect cube? Yeah, it is, because it's divisible by 3. So put y12 with the perfect cubes if you're on the left-hand side. Is there a leftover to y12? No. What about 5? Yeah, well, I can't get the cube root of 5, so it's a leftover. Put it on the right-hand side. What is the cube root of y12? Answer, 12 divided by 3, which is y to the 4. And then the leftover, cube root of 5, there's nothing I can do about it. And here's the final answer. That's problem number 15 for our review. Okay, let me go up and get a new clean sheet of paper. I got pretty much some more time on on this video, so that's not the issue. Let's just get a clean piece of paper. Get rid of this one. And here comes, I hope, another one. Okay, great. No snags. Here comes problem number 16 in the upper right-hand corner. And what about the square root of 27, and I'm using weird letters now, OP to the 7th, times the square root of 3, O to the 4, and P to the, let's say, 10. Okay, how do we handle this one? So we've learned before that if they're multiplying each other, we can combine them. We've done that before. We've split others into 2. Now let's recombine this. So what do I have? 27 times 3. It'll turn into one big square root. 27 times 3 is 81. O to the 1 times O to the 4 is O to the 5. And P to the 7 times P to the 10, P to the 10 is P to the 17. And now let's resplit it into 2. Perfect squares on left and leftovers on right. Is 81 a perfect square? Yes. What about 05? Can I take that? Can I get a perfect square out of there? Yes. What's divisible by 2? The highest number beneath 5 that's divisible by that invisible 2. O to the 4. O to the 4 belongs here. And plain O to the 1 is a leftover. I don't need the 1 in the upper right-hand corner. P to the 17. What's the highest number divisible by 17 divisible by 2 that's beneath 17? Answer 16. 16 divided by 2 is going to be perfectly clean there. So it's divisible by 2. So P to the 16. What's the leftover? Plain P. P to the 1. 16 plus 1 is 17. Here are my leftovers. Here are my perfect squares. The rest is easy. Square root of 81, 9. Square root of O to 4, just divided by half. O to the 2. Square root of P to the 16 divided by half. P to the 8. And then no longer any square root sign, of course. No radical anymore, but there is a radical for the leftover. There's nothing we can do about it. O and P are left alone over there on the right-hand side, and this problem is over. That is problem number 16 for our review. 17. How do you handle 81 to the 5/4? So we said it's a two-step process. Step 1. Step 1 is you take the 4th root of, right? You take the bottom one, which is the 4th root of 81. What's the 4th root of 81? What's something times 4 copies of that number, and you multiply them, you get back to 81. The answer is 3. 3 times 3 times 3 times 3 is 81. So that's 3. So that's step 1. I got 3 here, right? Step 1. Step 2 is take that 3 and raise it to what? To the 5th power. 5th power. So that's going to be 5 copies. 3 times 3 times 3 and times another 3. So 81. 4 times 3 is 81. 81 times that last 3 is going to be 3 times 81 is 243. And the answer is, let me put it right over here, the answer, 243. I'll put them in both places. 243. That's the answer to number 17. Okay, here comes 18. Some of those trick questions. 18a. What if you had negative 11 to the 0 power? We talked about this way at the beginning of the semester. Anything to the 0 power, 1, problem over. 18b. What if you had 5 times 1/7 to the 0 power? Okay, we talked about PEMDAS. You have to worry about exponents first. So let's do exponent first before you do any multiplication. So 1/7 to the 0 power is 1. So I've got 5 times 1 going on over here because 1/7 to the 0 power is 1. Anything to the 0 power is 1. And 5 times 1 is 5. So the answer is 5. That's the story. Nothing more complicated than that. Okay, here comes an important problem, and I want a clean piece of paper for this. So I'm going up there, click this, get rid of this piece of paper, and we go here. 1 second. If I can do it, if I can manage it. Yep, here we go. I want a clean piece of paper for problem number 19. Okay, what if you've got minus 3 divided by 5 square root of 2 plus 3. And on top it says, if it gives you any instruction, it says rationalize the denominator. Those are the instructions. Okay, what are you supposed to do? You look at the bottom and figure out what its conjugate is. We've had that word many times. 5 square root of 2 minus 3 is its conjugate. You multiply both the top and the bottom by 5 square root of 2 minus 3. And you'll see what happens. You'll see that the denominator will get rid of the radicals. We'll rationalize the denominator. So minus 3 times 5 square root of 2 is minus 15 square root of 2. Minus 3 times the 5, the normal number times the normal number. And minus 3 times negative 3 is positive 9. So far, so good. All right, now we do FOIL. First times first. 5 square root of 2 times 5 square root of 2. What's 5 times 5? Let me keep track of it in scrap paper over here. What's 5 times 5? 25. What's the square root of 2 times square root of 2? 2, right? So it's going to be equal to 50. 5 times 5 is 25, and square root of 2 times square root of 2 is 2, so it's 50 times 2, 25 times 2, which is 50. Okay, what about 5 square root of 2 times negative 3? You know what's going to happen here with conjugates. It's going to turn into minus 15 square root of 2. But then the inside times inside is going to be positive 15 square root of 2, so they're going to cancel each other out. Hold on, bear with me for a second. And what's last times last? 3 times negative 3, which is negative 9. So these two are gone. And what's left standing at the end? 50 minus 9, which is 41. And what's on top here? Minus 15 square root of 2 plus 9. Here is your final answer. On some answer sheets, that could be your final answer. On some answer sheets, they will write minus 15 square root of 2 over 41 plus 9 over 41. They'll give each one their own denominator. That's what you might see on some answer sheets. Don't forget the minus is part of it. Minus is part of it. It's part of the answer. Okay, that was 19. Here comes the last problem on this review sheet. If I can get it in on this video, I might have to make a special video just for the last problem. It's a little bit harder. Number 20. X minus 7 over x squared plus 3x minus 10 divided by, whenever you have a divided by, we're going to have to flip it. I hope that sounds familiar, but anyway, let's just do it together. 2x minus 14 over 2x plus 10. Okay, so step number 1 is to take the second part of the problem and flip it and then multiply. So this is what let me show you exactly what I mean. Copy down x minus 7, copy down x squared plus 3x minus 10, and put a multiplication sign and then flip the second one. Put the 2x plus 10 on top and put the 2x minus 14 on the bottom. And now we have to factor all of those. We have to factor whatever we can. So x minus 7 is going to be x minus 7. Check out and factor that. You'll see what you're going to get is x plus 5 times x minus 2. And this is going to be times, factor that, you're going to get 2 times x plus 5. And the bottom will be 2 times x minus 7. These two cancel. X minus 7 and x minus 7 cancel. X plus 5 and x plus 5 cancel. And what's the final answer? 1 over x minus 2. There's only 1's on top left. And 1x minus 2 on the bottom. There's the final answer. Okay, that's the final problem on this answer sheet. Let me stop this video. Here we go.